So good day class. For today, we are going to discuss a new set of topic, and these two are very important key aspect in linear algebra, and that is dimension and rank. So for starters, let's have first a recall. So in our previous lesson, we have discussed about vector and vector spaces. So a vector is a line. It's like an arrow that has both direction or where it points and magnitude or how long it is. And direction to where it's pointing and the magnitude or the length is how far it goes. So let's use an analogy about this. So imagine you're giving directions. Let's say, suppose you say walk 3 steps forward and 4 steps to the right. So that's a vector. It tells you how far and which way to go. So in math, we write that as a list of number. For example, 4, 3 meaning 4 right and 3 forward. So in our example here, we often write vectors as a list of numbers, like in 2D, quantity AB, or in 3D, quantity XYZ. While the vector space is a collection of vectors where you can add any vectors in space and the result is still in that space. Or you can multiply a vector by a number scalar and that result is still in that space. So think of it, a vector space like a world where vectors live. So again, it's a collection of all possible vectors that follow certain rules. So using this analogy, you think of a sheet of paper. So any direction you draw a line or arrow on that paper, then that's a vector. So all possible arrows you can draw on the sheet from a vector space is a 2D one. So imagine a room. All arrows in all directions form a 3D vector space. So these are some important features of a vector space. You can add vectors. Example, if you walk 3 steps forward, then 2 steps forward, that's the same thing as walking as 5 steps forward. Vectors add up to make new vectors. And also you can multiply it by numbers. So if you double a vector, for example, you walk twice as far in that same direction. So it's still part of that space. There's also what we call the zero vector. It's like staying in that place, You stayed on that particular place. 0, 0 means no movement, okay? So let's define what is dimension and what is rank. So let's focus first on dimension. So by definition, dimension of a vector space is the number of vectors in a basis for that space. So what is a basis? A basis is a set of linear independent vectors that span in that space. So the basis is a set of these independent direction arrows. So in simple definition, dimension is like the number of directions you need to describe something in a space. So the number of basis vectors is equal to dimension. Let's think of this analogy. So imagine you are in a room. To describe where is, you need to say how far it is from. For example, from left to right, or from floor to ceiling, and from front to back. So you need 3 directions, which is equivalent to 3 dimensions. So R3, or 3 dimension, which needed 3 basis vectors, example is where we live in this world. This world is composed of 3-dimensional things, right? We can move front and back, left to right, and up and down. So take a look at that picture in our screen. So in geometry, it is well explained. A point is an undefined term, and a line is where you can move left to right. In 2D, you can move left to right and up and down. And in 3D, you can move left to right, up and down, and front and back. And also there is 4-dimensional. Although it does not exist in our world, but in our imagination, we can imagine it, right? So now let's move on to what is rank, okay? So by definition, the rank is the number of linear independent columns or rows in the matrix. So rank tells us how much real information is in a matrix. So imagine you write 3 different sentences, but 2 of them are just repeating the first one in different words. You really only gave 1 new idea. So the rank of your writing is 1 because only 1 sentence gave new info. So in our example below, in the math matrix example, A is equals to 1, 2, 3, 2, 4, 6, and 3, 6, 9. So if you could just observe from row 1, looking by our row 2, so our row 2 is just the same as 2 times the row 1. 2 times 1 is 2. 2 times 2 is 4, and 2 times 3 is 6. So only row 1 is unique, or what we call independent. So the rank of this matrix is 1. Okay, the same as for the row 3. 3 times row 1. 3 times 1 is 3, 3 times 2 is 6, and 3 times 3 is 9. If you could observe, row 2 and row 3 is dependent on row 1. So our row 1 is independent So the rank is only 1. So next, let's talk about dimension theorem, or also known as the basis theorem. So the theorem statement states that if a vector space denoted by symbol v has a basis with n vectors, then every basis of v has exactly n vectors. The number n is called the dimension of v, written as dimension v is equals to n. So in simple definition, if a space has a basis with n independent direction arrows or the vectors, then any other basis for that space will also have exactly n vectors. Meaning, you can use different set of vectors to describe a space, but you'll always need the same number of them if they are truly independent and span that space. Okay? Okay, so next up class, my next co-reporter will show you an examples on how to use the basis theorem with the formula of dimension of v is equals to n, where v is the vector space and dimension of v is the dimension of vector space and n is the number of vectors in any basis of v. So thank you for listening.